order. Okay. All right. So I finished grading array one and also the binary search algorithm um, trace. You can look at your score. Okay, I do not provide very detailed individual feedback. For people who do not get a perfect score, you need to compare your trace against my trace. Okay, I talked about the solution on the due date, so you might need to take a look and compare between the two and find out how you lost the points. Okay, because it's usually either the format or somehow you miss certain things that is causing you to lose some points. If you cannot figure out why you lost some points, then you might want to talk to me during the office hour. The official office hour is right before class from 8 to 9. And I know sometimes people cannot wake up earlier and go to class, just to go to the office hour. So I'm typically available also after class as well. So I have an hour and a half from 10:30 to noon time that is also available, because I typically do not have anything scheduled between my two classes in the morning. All right, so having said all that, let me show you where we are at in terms of the notes. So we are all done with the arrays. We are now at, we talked about local variables, and today's main topic is going to be the return value. All of these are related. Okay, that means we are basically stacking up the concepts of calling or invoking a function and returning from a function. On top of that, we also have local variables that are only visible within a function, and now we're going to be talking about returning values. So before I move on and talk about returning values today, do we have any questions about local variables? Because that was the last topic that we talked about last Wednesday. So do we have any questions about that? Nope. Okay. All right. So now we move on to how to return a value. The module is deceptively short, okay? It only consists of one sample program, the trace of the sample program, and the actual instructions of how this particular mechanism works, okay? The difficult part is that it depends on things that you have already learned. Okay, so it is really, really crucial that we have a good understanding and a handle on all the previous concepts, before we get to this particular module. All right, so we're going to start with the rationale of why do we need functions to return values. So a function is essentially a block of code that performs some kind of operation. As a result, a function has some kind of information, usually has some kind of information to return to the caller. It's kind of like somebody asks you to do something, and typically that person who asks you to do something wants a critical status back. When you're done with it, it's like, at least did you find any problem doing what I told you to do? Okay, so typically you go like, nope, no problem, everything is done correctly. Or I ran into a problem, okay, I could not finish the whole thing. But the return value is not limited only to whether it was successful or not. Sometimes you're asked to say, oh, compute the product between these two integers. So your return value is going to be the actual value of the product. There are different mechanisms for a function to return information to the caller. The simplest and most commonly used mechanism is to go through a return value, which is what this module is going to describe. All right, so that's kind of the gist, okay, the kind of the idea of why we need to have return values for functions. Um, and here is an example. Okay, the example is kind of funny because I use function names that are based on Cantonese pronunciation for 7 and 5. Okay, so if you cannot pronounce these two function names, this one is tut. Okay, or if you want to say chut, that's fine. Okay, just pronounce it any way you want. Okay, yeah. And then this is how Cantonese in Cantonese, how 5 the value is pronounced. It is tip in actual pronunciation it is called okay, which is very hard for non-speakers to pronounce. So for the most part, it is an M followed by an ng consonant. Um, but that's basically the Cantonese pronunciation of the value of 5. So the idea is this function just returns a value of 7, tut returns a value of 7, and returns a value of 5. Okay, and the main function is going to have its own local variable, and this is why we need to have a good foundation on understanding how local variables work in the first place. But then now we have function calls that are not on a line by themselves. Instead, the function call is now embedded into where an integer can go. Because you can see how this is an addition, x is an integer, so we can certainly add two integer values together. But instead of supplying an actual integer value, I can now put in a function call in place of the integer value because the function has the same return type as an integer. When a function has a return type of an integer, then the function invocation itself can go any place an integer itself can go. So that is a really important statement about the return type of a function, which is highlighted on the projector right now. If the return type of a function is integer, that means the invocation of the function can be placed at any place an integer can go. What can we do with integers? We can add, we can subtract, we can compare. Okay, so all of those places where a normal integer value can go, a function call to a function that has that has a return type of integer, the function call itself can go to those places as well. So I'm going to pause a little bit and see if that concept is understood. Do we have any questions about that? Yes, go ahead. Not anywhere. You can, I mean, there are certain things you cannot do with an integer, but we can certainly add two integers, right? We can multiply two integers. We can subtract, two integers. We can divide two integer values, and whatever an integer value, we can also put whatever integer value to the right-hand side of an assignment when the left-hand side is just an integer. So all of those are typical places, but you can also compare integers. Less than, greater than, less than or equal to, greater than or equal to, and not equal to. So all of those comparison operators can also work on integers. So the idea is the invocation of a function that has a return type of integer can also go at all the places that I just mentioned. So in this very specific case, the left-hand side of the assignment is an integer type because that's how the local variable x is defined. So that means the entire right-hand side should provide me an integer value. Okay? So, but because the value of the right-hand side is really the sum of these two individual values, now I can also deduce that whatever this thing has to be an integer, and then this thing also has to be an integer. But remember what I said a little bit earlier. If a function has a return type of integer, then the function call can also go wherever an integer can be expected. This is where an integer can be expected, and as a result, I can make a function call to a function that has a return type of an integer. Same thing on this side here. This is also just, this side has to be an integer, and this particular function also has a return type of an integer, so it can also go wherever it can go to this place where an integer value is expected. Is that okay so far? Okay, so I have just described the basic idea of why we have function calls, and also where a function call can go when it returns a value. Okay, so if this is new to you, I know for some people this may not be entirely new to you, but if this is new to you, you might need to jot down some notes about your understanding of what I just said. And there's no need to copy everything verbatim because I'm recording the lecture right now, and it looks like everything is still good. But it is important to write down your own thoughts, okay, of your understanding of this particular concept. And on top of that, hopefully you guys got the chance to read the material before class because that really helps you to kind of go like, okay, I might have a general idea, kind of vague, of what we're going to talk about today, but it does help prime your mind when I actually talk about the example. So, do we have any questions before proceeding? We don't have any questions? Okay. So now we're going to focus on, what does this code look like when we trace it? Okay. In other words, when we execute this particular algorithm, what is it going to look like? So I'm going to do the same trick as usual. Okay. I'm going to make a screenshot of just this portion so that this portion can stay on screen when we talk about the trace. But, the problem with this trace is it takes up it's pretty wide. Okay, so I need to kind of shrink the browser window itself to make everything fit. So this will take a little bit of time to kind of arrange everything. Do you guys still want to see the clock like all the time? No? Yeah, we start at about 9 o'clock. So, typically you just need to kind of use that as the anchor when you need to fast forward to any part of the lecture. But we got some space here. I can just stash it over here. All right. Oh, okay. I don't mean to do that. When the title bar touches the top, depending on how much further I nudge it, it would also maximize. All right. So now we are actually going to look at the trace. The program starts execution in main, and in this case, main starts on line 7, and that's why the first line after the precondition is on line 7. At the point when we execute line 7, we have the comments column, which always is going to be there. We have the line number column, which should always be there as well. But none of the other columns have been allocated at this point. So that is really important to understand, okay? We only have two columns in use at the point when we have this row constructed. Are we good so far? So that means at this point of this class, most of, if not all of the variables are allocated and deallocated kind of dynamically. When you get into a function, we allocate some columns, okay? When we get out of a function, we deallocate those columns. And variables, local variables, fall into that category. We can see in the source code that x is a local variable, and in fact, we only talk about variables up to this point. There's no need to introduce global variables yet in this class. So as such, on line 7, when we get into the function, that is when x starts to exist. In other words, when line 7 executes, or when line 8 executes, it doesn't matter which one is which one, but when line 7 or 8 executes, we allocate the next available column on the right-hand side, and then we label it with the variable that is supposed to live on that column, which is x. So that's why we allocate a column, we name it, we give it a label, and then we also indicate that the initial value of x is unknown. Okay, now that part is very important in this class because in actual C and C++ code, local variables start with unknown values. Okay, so are we okay up to this row here, where the mouse pointer is? Okay, so this is all kind of like old stuff. Okay, this is stuff that we have already talked about. So the next row is new because when we get to line 9, we go like, okay, I would like to execute line 9. What is the last operation specified by line 9? What is the final operation that we need to perform on line 9? Yes, but is that the last thing that we need to do, or is it something that we need to do first, but there's another operation that we need to perform as the quote unquote last operation on line 9? Yes. That is correct. So the order of operation on line 9 is the last thing we need to do is once we figure out what the right-hand side evaluates to, then we take that value, whatever that turns out to be, and then use that to update local variable x. That is the last operation. But what can we do now? Can we do that now? Do we know what value the right-hand side has? No, we do not, right? Okay, so what we do is we now have to evaluate whatever is on the right-hand side of line 9. And we can see that, there's an add operation, there's an addition operation here. Can I perform the addition right now? Do we know the left-hand side or the right-hand side value of the addition? We don't yet. Okay, so we go like, oh, okay, there's so many things we cannot do. So that means now we can basically pick one side of the addition and go like, okay, let's figure out what the return value of that function call is going to be. Hmm? Yeah. So you can pick one, okay? Whether you pick, I know it doesn't sound like chat, right? Yeah. So we'll just call it shoot, okay? So we can evaluate shoot versus okay? It doesn't really matter which one because addition is commutative, which means it doesn't really matter which side you evaluate first. In order to perform the addition, you need both sides to be computed first. So typically we read from left to right, okay, in coding. So now we first go like, okay, let's call chat first, okay? And so now we perform the function call. But in a normal function call, we dynamically create a return line number column. This time we just create a return column without saying it is a line number. That is because when chat is done, it has to go back to line 9. There are other things to be done. So that's the first difference compared to function invocation and returning from the time when we talked about that about a week ago. Well, maybe more than a week ago. Is that okay? We're not only remembering a line number, we also need to remember when this function returns, what else do we have to do on line 9 in this case? So that information is captured by this particular cell. The first thing is we do have to spell out that when chat is done, we have to return to line 9. But then the question is, what else is on line 9 for me to do? So this is basically how I would encode what else we need to do. And for some reason, I can't select the entire thing because it's not appearing in one single contiguous piece, but I can still describe the individual part. So when we come back, this question mark is a placeholder. It's a placeholder for the invocation itself. Because in the code on line 9, we decided to read it from left to right, which means the first function call we want to handle is calling chut, right? So calling chut means it will return a value, and we just use a question mark here as a placeholder of the value that will be returned when chut is done. Is that okay? Does everybody understand the purpose of the question mark that is currently highlighted um, in the trace? Hmm. Well, we don't know what it's going to return at this point, but we know it is going to return an integer value. We know it's an integer value because the return type of truth is an integer. But otherwise, we don't know what value it is. We just know the positioning of that return value on line 9. Are we doing okay so far? Okay. So, okay. So that's what the question mark is. It is just a placeholder. Now you can see that, but what about the other function called okay? Um, well, we're going to handle one call at a time. Okay, so when there are multiple function calls on the same line, you can only handle one at a time. Even if they are calling the same function, you can only perform one invocation at a time. So if there are multiple question marks on the return column in this particular cell, something is not right. Okay, it should only have one and only one question mark. Are we doing okay so far? What about the rest of the line? What about the addition? What about the call to the other function called we don't really care. We just copy and paste it here. To remember that this is yet to be done on line 9. Is that okay? So line 9 is quote unquote quite complicated this time because we have to get back to line 9 several times in order to finish what it is specifying. So after allocating a column for return and populating it with the entire line 9, this one here is almost just like copying and pasting line 9 entirely into this particular cell, with the one exception that the function call that we're dealing with, which is truth in this case, is the only thing that is replaced by a single question mark as a placeholder, so that in the function, when we return the value, we know where that value is supposed to go. So this is a tracking mechanism. Are we still doing okay so far with the concept? Okay. So after this, we continue execution at the function that is called or invoked, which is truth in this case. So truth, is over here, and it doesn't have much to do. Okay, line 1 is nothing. It's really just kind of cosmetic. At least at this point, it's just cosmetic. And then we move on to line 2. So line 2, it specifies return 7. Okay, so this is how a function returns a value, is to use a return statement. So there are quite a few things we have to do when when we encounter a return statement like the ones on line 2 and also on line 5. Now, technically speaking, line 10 is also a return statement, but we look at that return statement in a very special way, so we are not going to include line 10 in this particular description. So between line 2 and line 5, when you encounter and execute a return statement, there are three things that you need to do. The first thing you need to do is to go to the leftmost return column, okay? And then what you do is you copy and paste it, to another cell, okay? So when we execute line 2, you can see that we basically essentially copied and paste the return cell all the way here. But you also do one more thing. You replace the question mark, which was here, with the actual value that we are returning using the return statement. The return statement on line 2 specifies we want to return a value of 7. And that's why the question mark is replaced by the actual numerical value of 7. That's the first thing we need to do when we encounter a return statement. The second thing we also need to do, well, actually, so I guess there are only two things to do. The second thing we need to do is to deallocate a column. No, I take it back. There are three things to do. The second thing we need to do is to copy and paste this entire cell all the way over here, because this is telling us, oh, when, okay? We are not quite getting back to line 9 now, but this is for us to remember when we do get back to line 9, what else do we have to do on line 9? Okay, so that's the second step when you execute a return statement. And then the third thing is easy. The third thing you need to do when you execute a return statement is simply to deallocate the column, because I have already utilized the information stored in the return column by copying and pasting here and also replacing the question mark with the actual return value. So that means at that point, I don't need that column anymore. And as a result, we deallocate that column. So those are the three things or three steps when we execute a return statement. Do we have any questions about those three steps? And those three steps should occur in that specific order. So I'm gonna pause here, okay, because this is kind of tricky, a little bit abstract. So I want to see if there are any questions about the three steps associated with the execution of a return statement. Right. Yeah, but we are concerned. So right now the focus is, what do we do on line two when we are executing the return statement? The calling part is already set up earlier, but when we execute the return statement, which is on line two, what do we do? The three steps are replace, copy and paste from the original cell to this new cell over here. That's the first step. Well, okay, that's the first part of the first step. Then what we do is we replace the question mark with a 7. Okay, both of those are quote unquote the first step. The second step is to copy this whole thing to a new row under line number so that we know that by the time we get to line 9, this is what else we have to do on line 9. That's the second step. The third step is to deallocate the column because the information that was stored in this column is now fully utilized and we don't need that column anymore. So that column is now deallocated. So those are the three steps with the rationale behind each of the three steps. Is that okay? So when I do this with another example, but this time probably using kind of more of a live illustration, I think it'll be more actually it's easier to understand because you get to see how I do it, using a spreadsheet. This is already done and it's without showing you exactly the operation in the table. It's just by describing it, it's actually a little bit harder to understand. So I will follow up with an actual live demonstration. All right, so I'm going to let you guys ask questions. Yep. Mm-hmm. Mm-hmm. How to trace a return statement. Mm-hmm. That's already done before this step. Yeah. Yeah. Okay. Mm-hmm. Mm, no, we still do not know what x is. We just know what the left-hand side of the addition is. That is the part. That is the only part that got replaced with a 7. And we still do not know what is the right-hand side. Right. So X still does not have a value. We are not ready to execute the assignment part yet because we are not even done with the addition part yet. Because with the addition part yet, at this point, at the point of our discussion, because when we get back to the caller, line 9 now looks like this, which means we still do not know what is the sum. We are not ready to perform the assignment because we have another function called in order to figure out uh, we have to we have to trace another function call in order to evaluate the addition, and then after the addition only at that time we can perform the assignment. Okay, so this is all about the ordering of the of what we need to do. in order to finish the operation. So in your mind, the most important thing that you have to think about is what do we need to do in what order in order to finish what line 9 is trying to accomplish. Is that okay? Okay, that's a good question. Any other questions before we move forward? And I want to go a little slow, on this topic. Yes. Oh, okay. We allocate a column. So line 9 does not return. Line 9 is calling two functions, but we can only call one function at a time on line 9. When you call a function, that is when you need to allocate a column so that we know, so that the function that is being called knows where to go back to continue operation. That's what the return column is for. Is it is not intended for main. The return column is intended for function, chut in this case, because when that function is done, it needs to know, okay, I'm done with a return value of 7. Uh, where am I supposed to go back to, and what do we do with this value of 7? That's the purpose of the column. The return column is for tracking that, all of that information. Yep. hmm So when you call a function, you go to the first line in the definition of that function, which in this case it's line 1. Line 1 doesn't do a single thing, right? But I do want to indicate that we go to line 1 because it's the beginning of the function being called. And then after line 1, we follow to, it is followed by line 2. So line 2 has, remember those three things that it needs to do. One is to figure out where's the placeholder where I need to change, because of the value I'm actually returning. Two, it has to use another line, another row, with the line number, so that I can indicate when I do go back to that line, what else do I need to do on that line? Because line 9 is quote unquote not the same as in the original code anymore. By the time we get back to line 9, the left-hand side of the addition is already resolved to a particular value. So it doesn't have to be done again. And that's why we need to copy and paste it so that we know, oh, there's only one thing left to do, which is to handle the right-hand side of the addition. Is that okay? And then the third thing it needs to do is to say, oh, since we have just utilized the information on this column by copy and pasting it here, that means we don't need that column anymore, so we deallocate that column. Is that okay? All right. And then, so now our execution continues on line 9, which is indicated by this particular cell here. So when you look at this line 9 here and compare that to original line 9, you go like, oh, okay, so the left-hand side of the addition is already resolved to a concrete value of 7. But the right-hand side is still a function call. I have no idea what value I should be adding to 7 to become the right-hand side of the assignment. So then you have to call in this case, which is going to be the same operation. When you are calling a function, you always have to allocate a column, in this case, a return column, and then you have to populate it with the entire line 9 as it is here. But you have to replace the actual function call, which is with a single question mark. The question mark, once again, is a placeholder for the return value of calling so that when the return value is specified, we know exactly where it needs to go, which is the indicated by the question mark here. Are we doing okay so far with that concept? Because this is just a repetition of what we have done already. We're just applying the same operations to the right hand side of the addition as opposed to the left hand side of the addition. So are we doing okay so far? All right. So the three things we need to do when we perform a function call that has a return value is to allocate the leftmost available column. Okay, we are reusing the same column here because it was already deallocated by this time. And then what we do is we copy and paste the entire line to this particular cell over here, but we replace the function call that is happening right now with a single question mark as a placeholder. And then we continue execution on the first line of the definition of the function that we are calling, which in this case is on line 4. Line 4 does not do a single thing. We move on to line 5. Line 5 is a return statement, and it also has three things to do. The first thing it needs to do is to copy and paste the original cell, including the question mark, but then you replace the question mark with the value that we are actually returning, which in this case is the 5. So we can see how when you copy and paste this cell over here, it would still have a question mark. The return statement replaces the question mark with the value that we are actually returning on line 5, which is really just the constant of 5. And that's why this 5 is here. And then the third thing we have to do is the second thing we have to do is to copy and paste this entire cell all the way over here. The purpose of doing that is so that when we return back to line 9, we still have two things to do on line 9. We have to remember what two things we still have to do. And that is the reason why in step 2, we have to copy this entire cell all the way over here as a reminder of when we get back to line 9, what else we need to do. And then the third thing we have to do is to say this entire column is once again not useful anymore because we have already utilized that column. So now the only thing we have to do is to deallocate that column and then move on to line 9 once again. But this time, when we get back onto line 9, it is fully resolved. There are no more functions that we need to perform. So now we are really just looking at x equals to 7 plus 5 as an assignment operation. Well, I don't think we need to do any calling anymore. We just have to evaluate the right-hand side, which is 7 plus 5, which is 12, and then use that value to update whatever is on the left-hand side of the assignment. And that's why 12 becomes the value of the local variable x of main. And that concludes line 9. So line 9 appeared, what, 3 times in the trace. The first time it appeared, we have to call chut, and then the second time we have to call and then only by the time we get back to line 9 the third time that we know exactly what the right hand side evaluates to, and as a result we can now update the left hand side as specified by the assignment operation, and therefore changing the value of local variable x only at that point. Are we doing okay so far with all that stuff? Okay. And then after line 9, we get to line 10. Line 10, is kind of special because when we return from main, that means the entire algorithm is all done. So as usual, okay, because x is a local variable, it is now deallocated. And then by the time we get to post, we only have these two columns left. All the other columns have been deallocated at this point. Are we doing okay or not? Okay. So what I'll do is I am going to, okay, so there's also, what has changed is, which is a very short description of what I already said as I go through all these trays. So what I'll do in this case is I'll give myself a new program to trace, and then we can use that as an opportunity to, I'll use it as an opportunity to kind of re-illustrate the steps and how you do it using a spreadsheet. All right, so we are going to CISP 300, and then go to shared. And I'm going to make a new spreadsheet for this particular algorithm that I'm just creating right now. So let's go ahead and create a new Google Sheet, and I'll name it in today's date. Okay, so today is 2025 0407. There we go. And then sheet one is just going to be uh, the algorithm itself. Okay, so I'm going to write the algorithm here. All right. So, oh, and then we say x equals to 0 if 1 does not equal to 0. X is updated to a value of 1, return 0, and brace over here. I'm not indicating the line number because the row number is already the line number. So when you look at the row number, that is the implicit line number. So I'm not using another column just to keep track of the line number. So what I'll do is to do about the same thing. Okay, so I'm going to get rid of this. And this time instead, we'll be using this block of code. So I will copy and paste or take a screenshot of only this portion. That becomes, yeah, go ahead. I'm This is new. So I'm illustrating how to do this, you know, using a spreadsheet. Okay. Does that answer your question? Okay. All right. So that's what we'll do. So hopefully this will help explain, the process of tracing it. Okay. So this is my actual trace. I label uh, column A comments as usual, and column B is just the line number. And none of the other columns are actually used at this point. So we only have two columns that are in use at this point. I don't really need the comments to be this wide this time. I'll just shrink it again. All right. Oh, yes. Okay. So where do we start? What is the line number to start with? Okay, 4 is good. Okay, so we'll say 4 over here. And then what do we do on line 4? Oh, I forgot to ask you about your question. So we're good? Okay. So on line 4, what do we do? We have local variables, right? So we have to create the local variables. So for each local variable, we only got one this time. What do we do? Allocate the leftmost available column, right? So column A is already used, column B is already used, column C is the leftmost available column. So when we allocate something, we have to label the column. So in this case, it is labeled as X because that's the name of the local variable. And we also have to indicate that it has an unknown value to begin with. Okay, so this part is really crucial. So that's basically line 4 is going to do. Line 5 really doesn't do a single thing. This is between line 4 and line 5. So if you want to say this is between line 4 and line 5, that's perfectly okay. Okay, to merge those two lines and say between those two, this is what's happening. And then we move on to line 6. Okay, line 6 is what does line 6 do? Line 6 is an assignment statement. The right-hand side is a 0. The left-hand side is x. So which column should I update to a value of 0? So from question mark to 0, so that would be, it should go here. Okay, so that goes from a question mark to a 0. Okay, very good. So now we get to line 7. So now we go like, whoa, Tech, you never talked about how to perform a call to a function that has a return value inside a conditional statement. You would be correct that I did not talk about that. but I already gave you enough general description before that you should know what to do when you encounter something like line 7. Because what I said was not specific to additions or assignment statement. What I said was any function call or the call to any function that has a return type of integer. That function call can go to any place where an integer value is expected. Okay, so now we look at line 7. We go like, okay, what is this symbol representing? Does not equal to. And can I compare two integers to see whether they are different or not? I can, right? Okay, cool. So that means, so if I'm comparing two integers, that means, the two sides of not equal to, they both have to be integer values. Do I have at least one side being an integer value? The 0 is definitely integer value. Okay, cool. The left-hand side is, we know it's an integer value because of the definition of the function 1 having a return type of integer. But we don't know what value it is returning yet. So that means, okay, so we can't really perform the conditional statement yet until we know the result of the not equal to, and we cannot know the result of the not equal to until we know what the left-hand side really is, which depends on the function call. So this is when we need to perform the function call to 1. So can someone remind me the 3 steps of calling a function that has a return type and a return value? We have to allocate a column. Yes, go ahead. Leftmost available column. Yeah, but it's on the right-hand side. Yes. We just call it return. Yep. And what should I put in this particular column? So- Okay, so line number first. Okay, this is on line 7. And what else do we need to do? We copy and paste the entire line 7. So that means, oh, okay, so that whole thing like this? Mm, almost, with one little thing that we have to adjust. The function call itself. What do we do with the function call itself? Yes, yes. We replace the function call itself with a single question mark because the purpose of the question mark is a placeholder. It's like, okay, we know this thing is going to give us an integer value. We're using the question mark to mark where the return value needs to go when the function specifies the return value. Is that okay? So this step is really important, okay? Because without this step, we don't know what to do with the return value when we get to line 2. Okay, so this is all we need to do when we get to line 7, and then we continue execution at the function that we are calling right now. There's only one function, which is also called 1, starting on line 1. Line 1 doesn't do a single thing, so we just kind of go like, okay, fine, we move on to line 2. Line 2 is a return statement. There are 3 things a return statement needs to do. The first one is to copy and paste the rightmost return column. Okay, in this case, there's only one, so it doesn't really matter, whether it's the rightmost or not, but we have to locate the rightmost one. So we copy and paste it. Okay, so this is where I think things can be a little helpful now that you can see how I perform the editing using a spreadsheet. So copy and paste. And then also part of the first step, we have to find the only question mark in that particular cell and replace it with the actual value returned by the return statement on line 2. Can someone tell me what value is line 2 returning? A single value of 1. So we replace the question mark with 1 in this case. Okay. And then the second step is to copy and paste it to 2 rows below so that when we get back to line 7, we know this is what is left of line 7 that we need to do. And then the third thing we need to do is to deallocate the column. So deallocating a column in this class is really just doing this, and I think it's Alt Shift 5 to strike out the label to indicate the column is once again available if I need it for something else. But in this particular algorithm, we actually don't do a single thing with it. So now we are back on line 7. Line 7 used to have a mystery of, oh, we are going to be comparing the return value of the call to function 1 to the value of 0 and see if they are different. We already know that they're different now because the statement, the, the conditional statement is now really just literally 1 does not equal to 0. So what is the Boolean value of 1 does not equal to 0? In other words, is it true or false? It is true, okay? 1 does not equal to 0 is true. So now we go to the comments column and do the usual thing of saying 1 does not equal to 0 is true. And then where do we go next? This is going back to conditional statement, okay? So where do we go next? Sorry? Line what? Line 7? We are on line 7 right now. The condition of line 7 is true. Where do we go? Line 8 is correct. Yep. So line 8 is correct, which puts a value of 1 in local variable x. And then we move on to line 9 does not actually do a single thing. We don't trace line 9. So now we get to line 10. Line 10 doesn't really have much to do other than deallocating the local variables of main. There's only one. So we copy and paste the label again and then strike it out, which is Alt Shift 5 using Google Sheets. And now we're all done. Alt Shift 5 is how you do a strikeout in Google Sheets. I'm not sure whether it's the same shortcut key in Excel, but you can probably figure that out too. All right. So, do we have any questions about this trace? Yes. Could you ask the question again? Okay, what do you mean by the first time? Can you specify the question using the row number? Row 6? Because when we are on row 6, we do not know what 1 is returning. The algorithm, the computer, can only do one thing at a time. It cannot eyeball the whole thing like humans can. So until you invoke function 1, we don't know what value it is going to return. So when we are here on row 6 the first time, we all we know is we need to call function 1 to find out what it is returning. So because humans, can eyeball the whole thing and we can go like, oh, we know exactly what 1 is going to return. It's going to return an exact numerical value of 1. But when you execute an algorithm, it does not do it that way. It has to do everything in very small steps sequentially, line by line. And that is what I'm trying to train you guys to do, is to think like the computer. Because until you know what the code is going to do line by line, okay, I don't think it's a good idea to start to write algorithms on your own at that point. Is that okay? So it's kind of like, this is my approach to, teaching a beginning class is I need to get all the fundamentals first, okay? So even though most people look at this code and intuitively knows what it is going to do, my focus is how it is getting it done. Because you have to understand that part in order to understand some of the more important concepts later on. So are we doing okay so far with this trace? Okay. Now, this material is not easy, okay? So it might take you some time to kind of process this. So you have to ask the three questions, okay? Um, what are we trying to understand here? Why is it useful? And how does it get the job done? Okay, so those are the three questions that you should probably be asking, well, I guess a lot with any STEM class, not just programming classes or math classes. It also applies to physics, chemistry, and so on. Are we doing okay so far? All right. So we do have a homework assignment. Okay, so the homework assignment is specified here. Obviously, I cannot trace the homework assignment, but I can ask to see if you guys have any questions about it. Okay, the homework assignment is not visible to you yet. Okay, so I'm making it visible now. It is due on the 9th, which is the Wednesday, but but okay, if I limit the scope of the second exam to only array operations, I can postpone the due date to like next Monday, which I think is probably better. So let me just do that. Okay, let me postpone this to next Monday. Hopefully, it is not just getting people to start later. So hopefully, this is giving people more time to really absorb the material and practice. All right, so the due date is now changed. This is the code that I want you guys to trace. Okay, it is in many ways similar to the code that we looked at, just now, right? Um, so it really is. I don't think this is going to be very difficult when people understand the concepts. Okay, when people do not understand the concepts, then it can be a little bit tricky. The only thing that is, I would say, not even tricky, but that's a little bit different, is on line 8. So you can see how on line 8, we are calling one twice. So remember what I said a little bit earlier. You can only handle one function call at a time. You cannot do both function calls at the same time, even though they are calling exactly the same function. It would not be any different from calling chut and separately, except you're calling the same function in succession. Yes, yes, you do. Now, whether it's the same function or not, you still have to reallocate the return column. But you also have to remember to deallocate after the first invocation so that the column is once again available, and then you reallocate it in the second call, in the second invocation. So this is the only part that I think is a little bit tricky, okay? But based on everything that we have talked about today, it should not be very tricky because I already pointed out all the things that you have to watch out for. For people who come into class late, you might want to re-watch the video because you might have missed something that is very important to do this homework assignment. Obviously, it would be nice if people are not late to begin with, okay? Because the content here is actually quite important. So do you guys have any questions for me? Nope. Okay. All right. So are we feeling confident that we can get the homework assignment done? Okay. So based on what we talked about today, okay, if all the material is understood today, the homework assignment is kind of more chore than anything else, okay? Just a whole lot of Excel or spreadsheet operation. So with this one, I think the only way I want people to turn it in is to use Excel or turn it in using a PDF. So, so this way I don't have to worry about people forgetting to share the document with me online. Yeah. Is that, well, I mean, if you prefer it that way, I can change the way things are turned in. You prefer? Okay. I will provide that option to people who want to do it that way. So, website URL if you're doing this on using Google Sheets, or you can upload if you want to use just a Excel spreadsheet. Okay, that's fine. That's okay with me. All right. So do we have any questions at this point? You can use Google Sheets now. Now, I don't have any template Google Sheets already created, so you're going to have to start one on your own. Okay, all right. So this class went a little bit faster than I expected, which is okay. I already have some material prepared for the next module, even though it's not entirely done yet. Yes, go ahead. No, I'm not gonna take role just because, there are a few reasons. There's not a whole lot of points for me to take role at this point. All right, so this is all done, and I do have a new module available. It is not linked into Canvas yet, so let me just put that in, and then we'll talk about that. So this is an external URL. Um, and this one is about parameters. All right, and they always add it to the bottom, which is not where I want it to be. All right. All right, so this is about parameters. And the introduction is very simple. I'm done with the trace, but I'm not done with the general description of what happens. So we'll start with the code here and also the rationale. Why do we need parameters? Return values are useful in order for a function to return a value back to the caller. Like, did you get the job done right? Yes. Okay. So it's useful for that purpose. For the most part, you generally do not have a whole lot of functions where there are no parameters, but you specify a certain return value. In other words, the examples that we went through in today's lecture, they're only useful in the context of demonstrating the mechanism of returning a value. So typically, in order to have a return value, you have to specify some additional things so that the function goes like, oh, okay, so you want me to do this with those two things that you gave me, and then I'll give you the result of that operation. So that's typically how it goes. Like in this example, I have a function called add, which does not do anything other than just taking two values x and y as parameters and then add those two and then use the sum of x and y as the return value. Add also has an integer return type, which means the invocation of add can go any place where when an integer can be expected. So in this particular sample program, I try to make it as simple as possible. So main has only one local variable x, and that particular local variable x is involved in the next assignment statement. The right-hand side of this assignment statement is simply a single call to add, but this time the new concept is parameters. So I'm using 23 to specify parameter x. I'm using 56 to specify parameter y, so that by the time I continue execution in add, x would be 23, y would be 56, so that when I perform the addition on line 2, I would basically just be adding 23 and 56, which has a result of 79. So the return statement will return a value of 79, and then the rest is just what we already talked about today. So do we have any general questions about the concept of parameters? It is a mechanism for the caller, which is main in this case, to pass information into the invoked function, which is add, so that the function itself can use those specified value to perform operations the way it needs to do it. Is that okay in terms of the concept? And also the rationale. Okay, this is the why. Okay, so in this case, the what is a parameter. The why is so that we can pass information from the caller to the callee, And then the mechanism, which is the how, is specified in the trace. So are we good so far? Okay. Now there's one statement here that I kind of neglected to mention. A parameter is similar to a local variable, but unlike a local variable, which starts with an unknown value, the value of a parameter is specified by the caller. Okay, so that's kind of ties in with things that we already understand, which are local variables. So are we ready to move on to the trace? Okay, we're good. Okay. So instead of just reading the trace like this, because I think reading the trace is a little bit harder because there's no, you guys cannot see how I do it, right? You cannot see how I make the trace. So I'm gonna kind of reuse the concept a little bit earlier and just kind of capture the algorithm on its own, and then I'll put the trace into today's lecture. So that would be, I think this is the correct one. Yep. Okay. There we go. So this is another one. This is trace with parameters. All right, we got another 10 minutes. I think this will be kind of like perfect timing for today's lecture. All right, so we got comments, we got line number, the precondition. Okay, I think I forgot the precondition in the previous one. So now we start with line 4 and line 5. Okay, between line 4 and line 5, we allocate local variable x of main. So this is nothing new so far. And x starts with an unknown value, like so. All right. So do we have any questions up to row 4 of the trace? I think this is like what, the third time we see this kind of mechanism. So now we move on to line 6. So line 6 is, there's a function call involved, which is add 23 comma 56. So we are now reapplying something that we just learned today, which is how do we invoke a function that returns a value, and that value is actually utilized by a line when the function is returning to that line. So now we know that we have to create a column. Okay, we allocate the leftmost available column, label it as return, and then we simply copy and paste the entire line 6. So we say this is on line 6, x equals to add 2356, and then the whole thing with a semicolon. Except in this case, that's not the only thing we need to do. So we actually need two more columns to the left-hand side of this. So we'll go ahead and insert two more columns over here. So as it turns out, every parameter has its own column. So in this case, x and y, they both have their own columns. With local variables, they always start with an unknown value. But parameters start with known values that are given on the line or in the code of the invocation by position. So 23 is the first thing in the call, so that's why it goes to the first parameter. And then 56 is the second item in the parentheses, so it goes to the second parameter. So this is new, okay? Column D, E in this case, representing the parameters is new. So do we have any questions about how we pass parameters to a function? They are dynamically allocated, just like local variables. But unlike local variables, which start with unknown values to begin with, like column C, the value of parameters are specified by the invocation itself. So when we look at line 6, 23 is called an argument. The first argument goes to the first parameter. The second argument goes to the second parameter. And then we have to construct columns for those because they are dynamically constructed just like local variables. And that's why I said parameters are kind of like local variables, except they always start with known values. Is that okay? All right. So now we move on to line 1 because that's the first line of the function that we're calling. Line 1 doesn't do a single thing. Line 2 is a return statement. except this time it is not returning a particular single constant value. We have to evaluate what is x plus y. But because parameters behave like local variables, so when we reference parameters, we follow exactly the same rules, which means even though there are two columns labeled x, we have to use the one that is the rightmost. So that means, x here on line 2 is referencing column D, not column C. Is that okay? That particular concept about local variables were talked about when we talked about local variables. We have to use the rightmost um, definition or the rightmost column with the name of that variable, not the other ones. So are we understanding why column D is referenced by line 2 and not column C? Okay, we're good. So y is easy. There's only one column labeled y, which is column E. So now we know that we have to retrieve the value of 23 and the value of 56, add those two together to be 79. So the return statement is actually just returning a value of 79. So what do we do when we already know what value we need to return? Oh, I forgot to do one thing. I did one thing incorrectly. This is not supposed to be the entire function call. What is it supposed to be? Nope, the question mark. That's right. Okay, I forgot to do that. Okay, because I have to replace the function call that is taking place with a question mark because the question mark is the placeholder so that the return statement knows which place is supposed to be changed when we execute the return statement on line 2. So now that we are on line 2, the first thing we do is copy and paste this entire cell, locate the only question mark here, and replace it with the actual value that we are returning. What is that again? What is the value that we are returning? 79. Okay, because it's 23 plus 56. Okay, so 79 is the value that we are returning, and that takes the place of the question mark. And then we have to copy and paste this cell to two cells below. So this way we remember when we get back to line 6, what is left to do on line 6. The third thing we have to do is to deallocate the return column, but this time we actually have three columns that we have to deallocate. Because at the end, when you're done with a function, a return statement always terminates the execution of an invocation of a function. So whenever that happens, if all the columns that got created or allocated for that particular function invocation, they all get deallocated. So that means we now have three columns to deallocate, like so. So Alt Shift 5 is strike out. So now we are striking out all three columns at the same time. So that means column D, column E, and column F are now once again available by the time we get back to line 6 in main. When we get back to line 6 in main, we have already resolved the right-hand side of the assignment. It's just 79. So we now can complete the assignment operation, changing x, which is column C, to 79. And let me just make this a little bit wider, like so. And then we move on to line 7. Line 7 marks the end of the main function. So that means it's time to deallocate the local variable of main, which is also known as x. Alt Shift 7, Alt Shift 5 to strike it out. And now we are all done. So are we doing okay so far? Okay, so this example only has the one single added element of using parameters. Okay, so we have 3 more minutes. For those of you who want to have more chances of practicing, I can give you some practice. Okay, so what I can do is I can give you, no, I'll give you the code. Okay, and you can do the trace. Okay, so I may not have enough time to save it, but I can at least edit it first. So I want to give you something a little bit on the on the tricky side, so that you have to really kind of think about it, to get it done. So let me go to mouse pad. There we go. All right. So I want you to do something like this. Replace this with add, I don't know, let's see, 12 and 7. Okay. Very minor change to the code, but it will alter the operation kind of significantly. Okay. So um, if you have time, okay, try to trace this one. And then on Wednesday, I'm going to give you guys a practice exam, okay, based on exam two of the previous semester. But because of the change of the notation, I basically have to write the entire thing first. Yes, question. Well, okay. So all I can say is to follow the instructions to the T, okay? And figure out the most important part here is to figure out the dependency. In other words, which part do I need to resolve first? Then I can resolve which other part, and then I can do this operation. So you have to think about the ordering of operation. Okay. Now, do we know what this program is going to do? Yes. Okay. We're going to add 23, 12, and 7 together, and then that's going to be used as the value to update X. We know what it is going to do. The focus is how it is going to do it. Okay, it's the mechanism itself that I'm focusing on here. Okay, so we'll talk about this when we have the time to talk about this, probably next Monday or so. On Wednesday, we're going to have a practice exam for exam two, so that's what we'll be focusing on. You can try to be more prepared for Wednesday by just reviewing the material on arrays. Okay, so linear search, binary search. So those are the two algorithms that we talked about with arrays. So that's going to be the focus on Wednesday. All right, I'll see all of you on Wednesday. The actual exam is next Wednesday, and the scope is up to and including arrays but not functions. Yeah, no functions. Yes, so it's only up to the arrays.